All right, so in 10.7, I'm going to give you these formulas, these super complex formulas that are actually used with in finance and in chemistry and all that kind of stuff to solve some word problems, basically. Okay, so you're going to have the complex formulas. I'm going to give these to you on the test, so make sure you write them down now so you know how to work with them on your homework, but I will give you the formulas. What you will need to do is you'll need to memorize what each of the variables mean. Okay, so I'm going to give you what the formula looks like, but you need to know what A, P, R, N, and T all stand for. Okay, so the compound interest formula is obviously used in finance. Okay, the total amount that you have, right, invested, I guess, or the interest, is equal to the principal, what you originally invested, or what you got in a loan, okay, times 1 plus the annual interest rate divided by the number of times compounded per year. So if I say annually, that's 1. If I say semi-annually, that's 2. If I say quarterly, that's 4. If I say monthly, it's 12. Okay, so you get the picture. To the nt power. Okay, the n is the number of times compounded per year, again, and t is the time since the principal investment. Okay, so obviously write that down. And the doubling time and half-life decay formula, right, are very, very similar. They're basically the exact same thing. Okay, these are to work with population. So with these populations, right, n is the future population. N sub 0 is the current population, so basically like what you have right now at the beginning of what you're calculating. D is the rate of doubling, T is time. The only thing that changed for the half-life formula is instead of the 2, right, for the exponential part of the function, it's a 1/2, and the H instead of D is the rate of halving instead of the rate of doubling. Other than that, same exact thing. So let's try to apply these to some examples. So you might be thinking why we're even doing this, how this applies to anything, and it really just comes into play because in order to solve these, you're going to have to use logs, okay, for most of them. All right, so for the first one, we're talking about interest, so we're going to use compound interest formula. Okay, so A equals P times 1 plus R over N to the NT power. Okay, I'm going to give you that. You need to know what all those things mean and pull those out of the problem. Okay, so some things that pop out to me right away is 16%. All right, compounded quarterly is going to be really important. That's going to give us one of them. Yield at $10,000 at the end of 5 years. Okay, so those are probably all the things we're going to need to use. Right. The other thing that's really helpful is to think about when you read the question, what's being asked? Well, how many dollars must be invested? So that means that's probably going to be the P, right? Because P is the principal amount that you invested at the beginning. Okay, so we're going to be solving for P here. So we should have A, R, N, and T. Well, A is yield $10,000 at the end. Okay, so A is 10,000. P we don't know. 1 plus R is the rate, 0.16, divided by N, how many times is it compounded? Quarterly, so 4 times per year, to the 4 times 5 power, because you're at the end of 5 years. T is time since the principal investment. Okay, so we just have to simplify this. All right, this one's pretty easy. Okay, we've got 10,000 equals P times, we need 1. You probably need to use a calculator for this. Plus 0.16 times divided by 4. Right, so you get 1.04. I'm going to raise that to the 20th power. Right, 4 times 5 power is 20. And you get 2.19. Okay, so you can just divide that. 10,000 divided by second answer. Or sorry, second negative gets you the answer if you want to use that. Or you could use 2.19. And your answer is P equals 4,563.87. Okay, so that's how many dollars you need to invest in order to get that type of return after 5 years. All right, number 2, we got population of a city was 3.5 million on April 1st, 1980, and it was 5 million on April 1st, 1990. Assuming exponential growth, find the month and year that the population will be 6.5 million. So because we assume exponential growth, we're going to be using our doubling formula. Okay, so that's n equals n sub o times 2 to the t over d power. Okay, we have to figure out what each of those are. That t over d is in my face. T over d. Okay, so things we have. We first need to figure out what our rate of doubling is, because they don't give us that. Okay, what they do is they give us an n sub o and an n, and they give us the time in between, right? The time in between these two is 10 years. Okay, so because of that, that'll help us find the doubling rate. Okay, so instead of using the millions, I'm just going to use it like 3.5 and 5, and I'll just know that I'm in millions at the end. Okay, so 5 equals 3.5 times 2 to the 10 over d power. Okay, that's what we have to solve for d. Okay, so in order to do that, what I would do is I would start by dividing by 3.5, so 5 divided by 3.5. Get that off that side. Okay, so we have 1.43 equals 2 to the 10 over d power. Right? Now we can log both sides, or you could write it as an exponential, or you could write it as a logarithmic function. Either way works. Okay, what I'm going to do is I'm going to go ahead and log both sides. So if I log that and this one, I can log. I can pull the 10 over d out, right, because that's an exponent, log of 2. Right, so I could just divide by 2 and solve for d. So we'll have, or I could multiply by d and then divide by log, right? But you could, either way, you can solve for d. So d equals 19.4. Right, 19.4. Alright, so that d is going to help us find the growth at 6.5 million. Okay, so I want to find out where we're at 6.5 million equals n sub o. You could use really either one. Let's just go ahead and use the, I mean, it just depends on what we're going from. So let's use 5. Times 2 to the t over 19.4 power. And we just have to solve for t now, right? Because t is going to tell us how long since 1990 we'll be at 6.5 million. Okay, so you can divide by 5, log both sides, just like what we did. So 1.3 equals 2. Let's just go ahead and log both sides right away. Log 1.3 equals t over 19.4 log of 2. And you can multiply by 19.4, divide by log 2. So 19.4 times log 1.3, close the parentheses, divided by log of 2. And t is 7.34 years, right? But we want to know the actual month in years. So obviously it's 1997, because we started with 5. Because our n sub o is 5, that means we're starting at April 1st, 1990. So we want to know where we're going from there. All right, so 0.34, that part of it, okay, in order to figure out what month we're in, how many months we've gone, multiply the 0.34 times 12, and you get about 4. All right, so it tells us we're 4 months after April 1st. Okay, so that's going to tell us we're going to be in August of 1997. Okay, August 1997. Now, that one's a very, very tough problem. Right, we'll do a couple of easier ones for you now to lighten it up a little bit. Right, so the half-life number 3, we're using the half-life equation. Same idea. We've got n equals n sub o times 1/2 this time instead of 2, t over h. All right, now they give us the half-life. They give us n sub o. They give us 7 days. So with those things, we can use that formula to solve for n. Right? So n equals n sub o times 1/2 times 7, or to the 7 over 3.8 power. That one's nice and easy. You can just type it right in your calculator. 100 times 0.5 to the 7 over 3.8 power. And you should get n equals 27.9 milligrams of gas. That's how much will be left after 7 days. Okay, number 4. Okay, we're in another half-life problem. We're going to use the exact same formula. I'm not going to rewrite it, since you can see it still. See what they give us. They give us the half-life. They give us 50 grams. We're decaying, though, to 40 grams, so we need to solve for t in this one. All right, so we've got 4d, the new amount is 40, equals the original amount 50 times 1/2 t over 23. Remember that we're in hours for t. Okay, so we need to solve this. Divide the 50 over, so 0.8 or 4/5, either way. Let's use 0.8 since we're using the calculator anyway. All right, 0.8 equals 1/2 to the t over 23. All right, log both sides. Okay, so we'll have, we could pull our exponent out, okay, to make a coefficient. So we'll have log 0.8 equals t over 23 log 1/2. Right, now we got to have to isolate t, get t by itself, so we multiply by 23, divide by log 1/2, so we'll have t equals, what you type in your calculator is 23 log 0.8 divided by log 0.5, or 1/2. So we can type that in, log 0.8 close parentheses divided by log 0.5, get t equals 7.4 hours. Okay, so it takes 7.4 hours to go from 50 grams down to 40 grams. Number 5 is a population growth dealio. Okay, we're going to look for the doubling rate, so we're going to use the doubling one again. So we've got n equals n sub o times 2 to the t over d power. Right, now they give us the population increased 12%. Okay, they give us 4 years is how long it took. We want to know what the doubling rate is. Okay, so for this one, it's a little bit tricky. This 12%, right, tells us the increase of n from n sub o. So what I'm going to do is I'm going to do this little substitution. For n, I'm going to plug in 1.12 n sub o, right? 12% more than what n sub o is, equals n sub o times 2 to the 4 years over d. Okay, well, when you divide both sides by n sub o, the n sub o's cancel each other out. Okay, so that's why the n sub o really doesn't matter that much. You could do that simple substitution. So now you could just log both sides. Log 1.12 equals 4 over d log 2. And go ahead and answer the question. So we have, you can multiply by both sides by d, divide by log 1.2, and we get 4 log 2 divided by log 1.12. You get d equals 24.5 years. That's how long it would take to double. And the last question for us for this section is just an investment problem again. All right, so we're going back to the investment. Got A equals P times 1 plus R over N to the NT power. We've got a $4,000 investment, so that's P, 5 years, invested at 8%, compounded quarterly. Okay, so we just need to find A. All right, it should be a simple calculation. 4,000, 1 plus 0.08, 8% over 4, compounded quarterly, 4 times 5, so 20th power, so we can just type this straight across. 4,000 times 1 times, parentheses, 1 plus 0.08 divided by 4, all to the 20th power. And you get A equals $5,943.79. And I know that seems tough, but we'll do some more in class, I promise.